Alright, in this video I hope to go over pretty much all of chapter 18, the important things you need to know, which you do need to know this stuff, it's really good stuff. So take notes, write stuff down, and I'm going to go over the problems. So by the end of this video you should have all the problems done for chapter 18. There's only 5, they're not so hard or anything, there's some tricks and stuff that you need to know. So, and I'm going to try to do it in less than 45 minutes, so wish me luck here. Alright, so first I have Desmos up here with our unit circle. I put the units in pi and radians because when we're graphing sine and cosine and stuff, we're going to do radians, which means that it's hard to tell this is a unit circle, but see x squared plus y squared equals 1. So this is 1 right there. Yeah, and here, because that's obvious, right? That's 2, that's 1. So this is our unit circle. So first they say sketch sine of x. Okay, you just need to know what sine of x looks like. And remember, sine is the y value. So just always keep that in mind. Sine of the angle here, sine of x is the y value, how tall it is. So we're going to start right there because that's where we start in math. You start right here in the circle and go counterclockwise, right? So sine, the y value starts off at 0. So our graph at 0 is 0. And then it gets bigger and bigger until it's 1 at pi over 2. So pi over 2, it's 1. And then it goes back down to 0 at pi. So pi at 0. And then it becomes negative. The y value becomes negative. It goes down here to negative 1 at, let's see, that's 3 pi over 2. So 3 pi over 2, it's negative 1. Why do I have a mark there? Negative 1. And then it goes back to 0 here. Okay, so it looks like that. So now I just connect the dots, and and then if we go in the negative direction, if I go negative pi over 2, right, I can just go backwards now. Negative pi over 2, it's going to be negative 1, right? That's negative 1 there. So it's negative 1, and then I go back to negative pi, and it's 0. So I can go in the negative direction, which is clockwise, of course, and the positive direction, and it still works. Now I connect it with a nice curve. And look something like that. And of course it goes on forever because I can keep going in the circle backwards and forwards forever. Okay, that's what sine looks like. Again, the y value. And I missed that, didn't I? That's terrible. It's got to go through the center. There it goes. All right. Now let's do cosine. Cosine is the x value. So where does... wait, they don't... Okay, if we did do cosine, they don't ask us to, but it's the x value, right? So the x value starts at 1. So at 0, it's actually 1. So it would be right there. And then, as we go up, it becomes 0 here, right? Here the x value is full, but the x value gets smaller and smaller to 0. So pi over 2, it's 0. And then it becomes negative 1. It goes to negative 1. So at pi, all the way here, we get to negative 1, right? It's negative 1 there. So right there. And then it becomes 0 again at 3 pi over 2. And then it becomes 1 back up here at 2 pi, so it looks like that. So our cosine curve would look something like this. Peaks out there, goes like that, keeps going. Okay? Looks just like the sine curve, but it's shifted to the left. Right? Here it's 1 here, or sine is cosine. Sine is shifted to the right. Is cosine shifted to the right by pi over 2? Or cosine is sine shifted to the left by pi over 2. So we can use our shifting skills, some of these previous chapters, to just kind of write one in terms of the other. They're exactly the same shape and everything, just shifted over. Now what's fun is to see how well I drew them. So let me click these things in here. So sine, there's sine. My black one, yeah, it's pretty much on top of the red one, right? That's pretty good. Let's see how my cosine did. Cosine, it was even blue. They kind of match pretty good. So I stopped there, right? But okay, so you can see sine, cosine, pretty easy. Now, what they want us to do, though, for the second one in the problems is sine squared. Okay, we want sine squared. So let me put their sine up there because theirs is prettier than mine. So their sine, I'll erase all my stuff because it's getting confusing. We don't need the circle anymore either. So sine squared, basically we square this, right? Now the biggest it can be is 1. 1 squared is 1. And squared things can never be negative. So this point stays the same if we square this graph. 0 stays the same. 0 squared is 0. 0 squared is 0. But where it's negative, it becomes positive. So negative 1 squared is 1. So all these become positive. And when you square a number less than 1, it's even smaller. So all these numbers are going to be smaller. It's going to be underneath the red part, but it's going to reach 1 here. So the graph is going to be a little bit beneath it. So something like this, but it still goes to there. It's going to be a little bit beneath it. And it comes down to here, and then it goes back up again. So it goes back up again, right? Can never be negative. It goes back up again. And the same thing over here. So it goes to 1, and it's always a little bit beneath the other curve kind of thing. Something like that, okay? Sine squared, always positive, and it's always less than 1 except where it's 1 is equal to 1, but like 0.9 times 0.9 is 0.81. So it's always underneath the original sine one. Okay, let's see how I did. I think I did pretty bad on this one. So I'm going to click on sine squared there. Not so bad, right? See, it's, a little bit, yeah, not so bad. I did pretty good, actually. Let's see what there's sine, and let's take off mine. But you can see how, okay, it's always a little bit beneath it. Right? It's a little bit beneath it, except it only matches there and it's 0. 0 squared is 0, 1 squared is 0. Everywhere else it's less than 1, so it's a little bit beneath it. Okay, that's kind of cool. Now they want us to graph 1 over 1 plus sine squared. So 1 over 1 plus sine squared. So now you're thinking, why do we got to do that, right? Let's click on that and let's draw what it looks like. But we're not going to give up that easy, right? It's not so bad. So I'll leave the sine squared up here. We can think about this. There's sine squared. We want 1 over 1 plus that. Okay, here's why it's not so bad. Well, let's look at this point. Where it's 0, 1 over 1 plus 0 is 0. So all the zeros are going to be in the same place. Okay, because let's just, oh, wait. Sorry. Messed that up. When sine squared is 0, we have 1 over 1 plus 0, which is 1. Sorry, so it's going to be 1. So that's 1. So wherever it's 0, it's 1. So we can get that point. Now, what about when sine squared is 1, when it's the biggest? Then, this is going to be 1 over 1 plus 1, which is 1/2. So here, it's going to be 1/2, which is right here. So there's a half. And it does the same thing over here, right? Now, all we got to do is connect the dots. And it's going to be some kind of curve. Since sine squared is curving, it's going to be some kind of curve. So all you got to do is connect the dots. So look something like this. And I did a kind of bad job connecting the dots. Okay, this one's good. Look at that. My peak was, oh, that's okay. That's terrible. Good thing I can erase. So it's going to go to 1/2 there. So like this, go to 1. Oh, wait. That bottom's out there. It goes back up. All right. Okay, that one's bad too. Okay, fix that. So here we go. Yeah, something like that. So we didn't need to graph it first, right? It's not so hard to figure out. Just get the biggest point where it's 0 and the smallest point where it's 1, and then it's somewhere in between all the other ones. Pretty easy to do. So we don't have to now, but of course it's fun to see how I did. Let's see how I did here. Take away that one. Oh, pretty bad. I missed the peak there, right? It peaks there. That one I did pretty good. That one's terrible. That I did pretty good. That one's terrible. Okay, well, whatever. All right, so that's it. Now we're done with number 1. We've done problem number 1. Let's look at problem number 2. They say sketch the absolute values of these things, the absolute value of sine and cosine and stuff. Well, that's pretty easy. There's our sine. Absolute value just means it never goes negative, right? So if we want the absolute value of sine, this one's good. Oh, it goes negative, so it just looks just like the other one. So it's just a whole bunch of humps like this, right? So just a whole bunch of humps like that. So that's what the absolute value looks like. Just never goes negative, bunch of humps. Okay, that's sine. And cosine and tangent are the same thing. Let's look at cosine and tangent. Cosine, of course, it just starts here, right? It's the sine wave that starts there. It's a little bit behind it. So it's the same thing. It's just a bunch of humps that look like this. Just the humps are offset a little bit. Something like that. So that's easy. Now, what about tangent? We haven't graphed tangent yet. Tangent is sine over cosine. And we know that for our unit circle, let's look back at our unit circle for tangent. tangent is sine over cosine, or opposite over adjacent. Here there's no opposite, so it starts at 0. And then at 90 degrees, the opposite is, let's see, so opposite is 1, but the adjacent is 0. We have 1 divided by 0, so it goes to infinity. So at 90 degrees, it goes to infinity. And then how about if we go negative, right? If we go on the other side, so then it starts at 0 again and goes to negative infinity, because the opposite is negative, right? Yeah, the opposite is negative height, and it's still positive adjacent. So it goes to negative infinity, so it looks like that. So if we wanted to do the absolute value of it, this part in the bottom just goes to top. So it looks like this bowl kind of thing, or some kind of thing like that. And then that just keeps repeating. So like this to there, and this to there. Yeah, something like that, right? So this never gets negative if we do the absolute value. One thing I haven't mentioned here, but it's really important. We can see that the period of sine and cosine is 2 pi. Right, that's the full cycle. From going up to going up is 2 pi. Or from peak to peak is 2 pi. Or from trough to trough is 2 pi. From the same point in the curve to the same point, that's 2 pi. So it is called 2 pi periodic. So in other words, sine of theta plus 2 pi is the same thing as sine of theta, because 2 pi, you're right back to where you started. It's always the same thing. And sometimes what people write there is you could say sine of theta plus 2 pi n, where n is understood to be an integer. So n can be plus or, well, you can write it lots of ways. So you put a dot, 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 -2, -1, 0, 1, 2, dot, 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 forever, right? So n is always, can be 0, n can be 0, then it's just theta. But where n is just an integer, so you can write it that way. Okay, and that's always equal to sine of theta because it's periodic by 2 pi. And cosine's the same way. Now tangent, as we just saw, is actually periodic in pi. It's so right. It went from in pi from here to here. It makes that full cycle. That full cycle. So it takes up only a pi's width for its full cycle. Right. We saw the absolute value look like this, or the regular one look like that. That's only pi width, right? Negative pi over 2 to pi over 2 is pi. So tangent is pi periodic. So you could say tangent of theta plus pi n is equal to tangent of theta. You add pi to it, it's exactly the same thing because it just repeats over and over again by pi. Okay, good. Now we're done with problems 1 and 2. Hooray, we're cruising. Let's look at number 3 here. It says, oh, I don't need the screen anymore, I don't think. So, yeah. Unit circle might be nice, but I can draw my own unit circle. All right, so 18.3 says if 0.3, and there's an A, B, and stuff here. Say if cosine theta is equal to 24/25, what are the two values of sine theta? So cosine theta is equal to 24/25. What could sine theta be? We did ones like this in the last quiz, so I think you guys are pretty good at this. I like to draw a picture, right? So I said unit circle here. So cosine is the x value. 24/25, that's practically 1, right? That's like right here. So there are two y values. There's this y value and that y value. That's why they said there's two answers. Because for every x value right there, there's two y, except if it was 1. Then there's only one y value, which is 0. But as long as it's not 1 or -1, there's always going to be two answers. We want to find both. So let's see. So there's our triangle. The x value is, okay, cosine theta is adjacent divided by hypotenuse, right? So adjacent divided by hypotenuse. Caught another horse. Yep, that's right. So we can think of it this way, or we could draw the triangle. So yes, let's look at let's look at the triangle thing and just draw our triangle like this. So if the hypotenuse would be 25, the adjacent is 24, here's theta. So what's this here? And that would be 20 square root of 25 squared minus 24 squared. Right, the hypotenuse minus that one is what this is. And I think they did this so it's actually a nice number. It actually turns out it's a magic triangle. So 25 squared minus 24 squared is 49. So that's the square root of 49, which is 7. So this is one of those magic triangles, 24, 7, 25. So sine theta then is opposite over hypotenuse, so 7/25. But it also could be negative 7/25. That's where this kind of fails you. You don't really see that here, right? But remember there's two numbers. So if the height here is 7/25, that's what sine tells you, right? Sine tells you the height. So the y value there is 7/25. It could also be negative 7/25. So sine theta could be 7/25 or negative 7/25. Those are the two possible values. That's again, the triangle thing only gives you one of them. You really got to look at the unit circle to kind of see that there's two numbers there. They're the same. They're going to be the same, but yeah. Okay, that's part A. Part B, if sine, so they're giving us more of these things here. All right, I'll keep that up. I'll do part B over here. So part B says, if sine theta is negative 0.8 and theta is in the third quadrant, so they're limiting us now. They're saying, okay, just choose one of them because there's going to be two answers. Sine theta is negative 0.8, theta is in the third quadrant. What is cosine theta? So sine theta is negative 0.8. Okay, so we draw our circle. Sine is the height, negative 0.8, the height, so this is 1. So 0.8 is like somewhere like right there. And it could be here, right there. Wait, no, that can't be there. It's negative. It's over here. Two places where it's negative 0.8. This is negative 0.8, right? That's negative 0.8 there. So that it's at 0.8 down here. Get the idea. However, they want the third quadrant. Let's see, this is first, second, third. So they want this one. So cosine is going to be negative, right? Cosine's the x value is negative here. So we know that we're going to choose the negative cosine because it could be positive. The x value could be positive. They want the third quadrant, so we know our answer is negative. Okay, now we can do the triangle thing. If sine theta is 0.8, so let's think here. So sine theta, sine is some old horse, opposite over hypotenuse. Over hypotenuse is equal to 0.8, negative 0.8. So we draw our triangle. Opposite is 0.8. Hypotenuse is 1, right? Because that's like 0.8 divided by 1, so opposite over hypotenuse. You can always divide by 1, so that's 1. So what's this? So this is the square root of this squared, 1 squared, minus 0.8 squared, which is 0.64. Ooh, I think this one might be nice too. That's square root of 0.36, which is 0.6. So this side is 0.6. So cosine theta then, running out of room. I'll write it right here. Cosine theta then, the adjacent is 0.6 divided by the hypotenuse, right? It's adjacent divided by the hypotenuse. Okay, can you read that? It's going to be a mess here, sorry. Cosine theta is adjacent, which we just figured out is 0.6 divided by hypotenuse, so that's just 0.6. But we want this one here, so it's negative. The x value is negative right there. It's negative 0.6, so negative 0.6. And we circle it because it's a mess and never going to find an answer the other way. Negative 0.6. All right, good. Hopefully that worked out for you. And then finally, part C says if sine theta is 3/7, okay, I have to erase this side. So I'll erase this side. Okay, we did stuff like this in the last quiz, so this should be pretty straightforward for you guys. If sine theta is 3/7, what is sine of pi over 2 minus theta? So sine theta equals 3/7. What is sine of pi over 2 minus theta equal to? Oh my gosh, what is going on? What's with this pi over 2 minus theta? Okay, there are some things we should know. Okay, and they work this out in the text of the book, and which is great. And so you should copy these things down. I'm going to do it all right now. So this is going to take a little while. Well, hopefully not that long. So copy this stuff down. These are relations that, or I mean, you could have a trig sheet somewhere and stuff, but these are just easy things to figure out by shifting the sine and cosine curves. We can use our shifting things like, okay, minus, you shift it this way, pi over 2. Remember how we talked about sine and cosine are basically the same thing, but they're shifted by pi over 2. So you take away from one, it's equal to the other one. Okay, so first thing here is that you should know is the whole odd even thing. Sine of negative theta is equal to negative sine theta. That's saying that sine looks like this, right? So if it's on the other side of the x-axis, it's the same value, but it's negative. So if it's, this is the same value as that. This is the same value as that. So it's negative. They call that odd. It's really nothing to do with odd, like 3 is an odd number. It's kind of unfortunate terminology. But they call it odd if the function is exactly the same on the other side of the y-axis. The other side of the y-axis, but negative. So positive one side, negative the other side. Okay? So sine's obviously like that. Now cosine starts here. Cosine's the same on both sides. If it's here, if it's negative 0.5 is this. At 0.5, it's exactly the same thing. So cosine of negative theta is the same thing. It's the same thing as cosine theta. And they call that even. Functions that have that property, you put in a negative x and it's the same thing, doesn't matter. They call that even. X squared is even, right? Put in negative x, doesn't matter. So it's an even function. X is an odd function. Put in negative x, it's negative x, same thing, but now it's negative. Okay, that comes up a lot, so remember that forever. Okay, forever. Think about it. Okay, forever, forever. Okay, got it. Remember that forever. Now, other ones that they work out here. So I'm just going to, these are just the shifting ones. So sine of theta plus pi, if we move sine over by pi, it's the same thing, but it's on the bottom. So it's now negative, right? It's the same curve. Like if we move it over pi, like here we move it over pi, it's the same thing, but it's negative now. Instead of being positive, it's negative, which makes sense. And cosine's the same way. If you add pi to it, it's the same thing, but it's negative. It's now on the bottom. Okay, so that can be useful. Another one, why did I put 2 there, 3, 4? Oh, one is that they talked about in there, which we should say, is the whole idea of they're periodic. So sine or cosine of theta plus 2 pi n is equal to sine of theta. Same for cosine, but remember tangent is pi periodic. Tangent of theta plus pi n is equal to tangent of theta. That's what number 1 was that I started as number 2. But we already went over that. So, okay. Number 4 is the pi minus. So sine of pi minus theta. And again, this is just shifting. It's easy to work out. Is just equal to sine theta. And cosine of pi minus theta is equal to negative cosine of theta. And you can just write these down, and you can easily figure this out if you had to, but sometimes it's like, okay, I already figured it out. Let me just look it up. We know how to get it. You just kind of do our shifting rules and stuff. Okay, finally, wait, no, almost finally, there's 6 here. Cosine theta is, okay, here's where they shift. Cosine theta is the same thing as sine of pi over 2 minus theta. They're just pi over 2 out of phase. Okay, cosine theta and sine of pi over 2 minus theta are the same thing. And then sine theta, this works the same thing. Sine theta is cosine of pi over 2 minus theta. This is just showing they're shifted by pi over 2. They're the same shape curve, just shifted by pi over 2. You can go back and forth between them by shifting by pi over 2. Number 6 was just the relation from the unit circle that you're going to use 1,000,000 times. We have our unit circle, and if we choose any point on it, any point on our unit circle, like that one right there, And then we look at the x value and the y value. And this is a unit circle, so the radius is always 1, right? Radius is always 1 unit circle. And we choose any point, we look at the x value and the y value. It's going to be a right triangle. So we have x squared plus y squared is equal to 1. But x is cosine. So we have cosine squared theta, it's called this angle theta, plus sine squared theta is equal to 1. That's called the Pythagorean relation because it's from the Pythagorean formula, right? And it just simply follows out from the unit triangle like cosine squared plus sine squared is equal to 1. Usually you write it sine squared first for some reason, because really it should be usually put x squared. This makes more sense this way, but if you do that, you put the cosine squared first. Most people write the sine squared first, but it doesn't matter, right? So that would be our number 6, the Pythagorean relation that relates cosine squared and sine squared is equal to 1. It's really useful, it comes up all the time. Remember that forever too. And if you forget it, it's super easy to figure out. You just look at the unit circle and do the Pythagorean theorem. Okay, those things you got to remember forever. Now we can actually do part C. It says if sine theta is 3/7, what is sine of pi over 2 minus theta? Well, okay, I'm going to erase this so you have it all down. We just use with our relation over there, which looks like we use this one. Sine of pi over 2, no, this one. Sine of pi over 2 minus theta is the same thing as cosine theta. So really this is saying, what is cosine theta equal to? Okay, because sine of pi over 2 minus theta is the same thing as cosine theta. Well, okay, we can do that. So 3/7, we draw our triangle. Sine is opposites, which is 3. Hypotenuse is 7, so this side is the square root of 49 minus this squared minus that squared minus 9, which is the square root of 40, which is not pretty. So this square root of 40, so cosine theta is adjacent square root of 40 divided by hypotenuse. So square root of 40 divided by the hypotenuse, which is 7. Okay. Now, is there only one answer? So let's think about that, right? This is always the tricky part. So we draw our unit circle. Sine theta is 3/7. That's the y value. 3/7 is about half, a little less than half, right? So right there, positive 3/7. There are two answers. For a y value of 3/7, the x value could be here or could be there, right? We don't know. They didn't tell us, so there's two possible answers. So if you'd stopped here and been all satisfied yourself like I was, you're only half right. It could also be negative, right? It's always going to be the same thing. It's the same distance away on either side, but it's negative. So really I should put plus or minus. Could be positive root 40 over 7 or a negative root 40 over 7 to give us a sine, a height of 3/7. So again, the triangle thing fails us for the other one, for the negative one. But just know there's always a negative, and if you do the unit circle, you can see how that works. All right, 18.4 is super easy. The last ones are real easy. So let me erase all this, and I think I'm going to get done in 45 minutes. This is awesome. You guys have all those memorized, or at least have them written down, or you have the book you can look at, so because they'll come up a lot. Okay, so 18. Yes. Let me put up the 18.4 there because at least I'll try to. Get rid of Desmos. Here we go. Make it bigger. Okay, so whoa, too fast. I made it too big. 18.4. Okay, so they say these graphs represent periodic functions. Describe the period. A period is a full cycle. Okay, now you can just draw in on your homework that you're going to be turning in. Okay, I want to see that you did this. Turn this in like a normal assignment. Just draw the full period. Okay, the full cycle. So what part looks the same? So it doesn't matter where you start, but here, like, so this one you just draw like that, right? Now you could draw like this, like doesn't matter where you start, you could start there, but that's easier, but it doesn't matter, okay, that's a full period. This one, I would just draw one of the things. Okay, that's the full period because it starts over again. You could start in the middle, and that would be really weird. It would be kind of hard to do. This one, oh, this is a tricky one, right? The full period is, let's see, I think it'd be a little one to the big one, back to where the little one starts. So from here, it starts again there. So that would be the full period. From the little guy going up to the little guy going up. That one's a little bit trickier to draw. Or you could start from the peak of the tall one to the peak of the tall one. Lots of ways to do it, but always from the same point to the same point. This one too, where do you start? It looks like it repeats right here. Right, so it goes up, goes down, repeats. So you could either draw this side or that side. So something like, yeah, I don't know. Yeah, something like that. And then this one is not like this one. This one's easier. It's the same always. It's like a sine wave, but it's called a triangle wave. It's or a sawtooth wave. It just is straight. So it's from like peak to peak or trough to trough, or from where it starts going up to where it starts going up. So you can make it look like a sine wave kind of thing. Wait, that's not right. It'd be a full cycle would be like where it starts going up to where it starts going up like that, or like this, or like that. Again, a full cycle, whatever. Lots of ways to do it. They just wanted you to understand what a period means, the full cycle. What's the full thing? What repeats? What part of it repeats? What basic unit then repeats over and over? Okay, I told you that part was easy. And then the last one, they want us to say, use a unit circle to solve for sine theta equals cosine theta. Okay, that's problem 18.5. So just sine theta equals cosine theta. How do we figure out what theta makes that work? And again, it's real easy by looking at the unit circle. So let's draw the unit circle again. So basically they're saying, when does y equal x? When does y equal x? That means when does the y value equal the x value? So or we could even just graph the line y equal x on here. That's pretty easy. And then it will right there and right there. And we know that's a 45-degree angle and everything. So the angle there would be 45 degrees, which is pi over 4. And then it would be this angle. Okay, what's that? Well, that's pi plus pi over 4. Right? So it's pi plus pi over 4. That would be 4 pi's over 4. That's pi, right? Yep, that's right. Plus pi over 4. So that would be 5 pi over 4. So our two answers are theta could be pi over 4 or 5 pi over 4. Now, we could also say, well, let's just go negative. Maybe let's just do the negative one and go that way for the second one. Then it's pi over 2 plus pi over 4. Negative. So it could be negative pi over 2 plus pi over 4, which is equal to, let's see, that would be 2 pi over 4. So negative 3 pi over 4 would be a perfectly good answer. It's the same thing. 5 pi over 4 and negative 3 pi over 4 are the same thing. You know, that's the thing about these things, is that there's multiple answers. Or we could just say we went around the whole thing and added 2 pi to it. That would work too. You end up in the same place because it's 2 pi periodic. The simplest way is this, right? Just keep going. Pi over 4, 5 pi over 4, or at least pi over 4 and negative 3 pi over 4 go one way, go the other way. It's the same thing. Okay, we are done with chapter 5. That only took me 34 minutes. Oh my God, life is good. So, hope you followed all that. It's kind of a review. I know you did a lot of this stuff in Algebra 2. We've already covered some of this stuff, so I'm going to go over it pretty quickly, and then we can move on to where it gets a little bit trickier in chapter 19 and 20. So we'll spend more time there. So, good. Hope that you learned something, and thanks for watching.